Now that we feel comfortable with measures of central tendency, we're going to talk about measures of dispersion. Now, these are how spread out our data points are. So the three measures of dispersion are range, variance, and standard deviation. Range is going to be the difference between our maximum and minimum. Variance is what we talk about as the average of the difference between each value and the mean. Now, in order to understand variance, you have to take every single data point, subtract it to the mean, and then we're going to be looking at what is the average difference in all of those numbers. This variance is not often used in the IB, but what we really often use is the standard deviation. And what is the standard deviation? Well, it is simply the square root of the variance. And this standard deviation, since we're square rooting it, it's going to give us a better approximation of how spread out our data points are to each other. So we're going to be using it really to see, are most of our data points centered around the mean? Or do we have a huge variety of data points and they're spread out in general? This number is never going to be negative since we are square rooting it, so we can't square root a negative number. It is super sensitive to outliers because outliers by definition are very far away from the mean. And for the data with approximately the same mean, the greater the spread, the greater the standard deviation. So the higher the number for standard deviation, the more spread out our data points are going to be. The final part to this presentation is talking about data transformation. Now, we're going to do an example together. Imagine you have been collecting agricultural data by measuring the heights of several plants at various stages throughout their growths. So you take your ruler in centimeters and you measure 2, 4, 4, 5, 7, 9 centimeters. Now, once you're done with that, you can calculate the mean and the standard deviation using your calculator. If, for example, you realize after completing your entire experiment that the measuring stick you used has been cut off and it was actually missing 3 centimeters. So instead of having 2 centimeters, the actual value is plus 3 centimeters, so 5 centimeters, and so on and so forth. So we're adding 3 to all of our numbers. Is your work all wasted, and do you need to do the experiment all over again to collect your data? So we have to think about this. How does adding 3 to all of our data points affect our mean and our standard deviation? And I encourage you right now to just pause the video and think about this. If you add 3 to all of your numbers, your new list is going to be 5, 7, 7, 8, 10, and 12. How does that change the mean and standard deviation? Now, if you've done it, you would see that the mean has changed and we're adding 3 to the mean. However, the standard deviation has not changed. And why is that? Well, the distance between each of our data points hasn't changed. So from 5 to 7, we have 2, and from 2 to 4, we also have 2. So since the spread hasn't changed, the standard deviation is going to be exactly the same. Okay, keeping this in mind, let's see what happens in scenario 2. Now, suppose your measuring stick was printed with the wrong scale, and all of the measurements need to be multiplied by 2. How will this change the mean, and will it affect the variance or standard deviation? If so, how? So everything needs to be multiplied by 2. So now your new data is 4, 8, 8, 10, 14, 18. Again, at this point, I encourage you to pause the video and try to think about what would happen to our mean and standard deviation. We would find out that our mean is also doubled, and our standard deviation is doubled this time. And why does our standard deviation change this time? Well, look at the difference between our data points. From 2 to 4, we have a difference of 2. But now from 4 to 8, we doubled that difference. So that's why our standard deviation is changed. So through these two scenarios, we find conclusions about data transformation. If we add or subtract a number to all of our data points, we'll see that the mean is changed in the exact same way, added or subtracted, whatever that number is, while the standard deviation is unchanged. If we multiply or divide a number to all of our data points, the mean is changed in the same way still, so either multiply or divide by whatever that number was, and the standard deviation this time is also changed in the same way.